Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem job sequencing. So we are given two arrays deadline and profit. So two arrays are given deadline and profit which represents a set of jobs. So every ith element represents a job where each job is associated with a deadline and a profit. Each job takes 1 unit of time to complete and only one job can be scheduled at a time. You will earn the profit associated with a job only if it is completed by its deadline. So we can see in the input array we are given two arrays deadline and profit. So each ith index tells us what's the deadline of that job, and after completing that job how much profit we will earn. And it is also given that every job takes 1 unit of time to complete. And now our task is to find maximum number of jobs that can be completed, and we have to keep in mind that we have to make maximum profit. So I hope you understood the problem statement. So if I tell you we are these four jobs are given, let's say example one is the same which I have taken here. So suppose these four jobs are given J1, J2, J3 and J4, and first job's deadline is 4 and second job deadline is first. So let's say deadline is given in the unit of days. So first job 1 deadline is 4 days, second job deadline is 1 days, third is 1 days and 4 is 1 day. So if suppose these are number of days, 1 day, 2 day, 3 day, 4 day. So how much days we have, we can see, we can we can just check what is the maximum deadline. So maximum deadline is what, 4. So we can say that the maximum deadline of any job is 4. So we can say that we have 4 jobs, let's say. So job 1, we have 4 jobs, and here the maximum deadline of the job is 4. Okay, so it means that we have 4 days. We can create let's say we have 4 days, all right. And we have, if we talk about job 1, its deadline is 4. So we complete this job on day 1 or day 2 or day 3 or day 4. All right, we have options on day 1, 2, 3 or 4. And if I talk about job 2, so its deadline is 1. So I have to complete this job on day 1 only. All right, so if I did job 1 early on the day 1, then if I go to other jobs I will see that they have crossed the deadline, because on one day I can do only one job. So job 2 has deadline 1, and I am on day 2 because I have done day 1 with job 1, and on day 2 I have I saw that the deadline has gone, and I cannot perform any jobs now because all jobs have deadline of day 1. So here my profit is what? Here my profit is coming from job 1 only. This is 20 rupees or whatever the unit is. And if I take another example, so maximum deadline of any job is 4. So let's say we have maximum of 4 days. And if I do job 2 first, so here I did job 2 first. All right, so I should write here, I should not write here 4. I should write here in the first while explanation I should write here job 1. So if I did job 2 first on the day 1, if I did job 2 first, then on day 2 I have the opportunity to do job 1 also, because the day 2 is less than the deadline of the job 1. So on day 2 I can perform job 1. So this my profit is coming from job 1 and job 2 is 20 plus 10. And you can see now after we cannot do any job because deadline is gone. And this is the maximum profit we can achieve. This is 30. So we can see our output, we can see, is coming. What have I written correctly? 4111 and profit 20, 10, 40, 30. Okay, okay. Now if I did job 2 on day 1, my profit is coming 20 plus 10. And but what if I I take another example, and perform, these are days, and I performed, let's say, job 3 on day 1, because on day 1 we maximum profit we are getting from job 3, that is 40. So instead of performing job 2, I performed here job 3, and on day 2 I performed here job 1. So now the profit I am gaining from job 3 and job 1 is 20 plus 40, is 20 plus 40. So now the profit is coming 60. So this is the maximum profit we can attain. So this is the answer also, 60, and we have to return the total number of jobs and total maximum profit. So total number of jobs we have done is 2, job 3 and job 1, and profit is coming 60. So what do we observe here? First of all, I observed here that I have to make maximum profit. All right, if we have, let's say, maximum deadline number of days 1 2 3 4, so I have to arrange jobs here in such a way that I gain the maximum profit. And if I have to gain maximum profit greedily, what should I do? I should, if deadline of job 1 is 4 days, so I should delay it. And I should do this on the last day, maybe job 1 on last day maybe, so that if I delay it, so that I will get many free time, much free time to do, to complete the jobs with lower deadline. All right, so my second observation is to delay jobs, or do, but do them in deadline, before deadline also, but at the last. So this will help me creating free time for the jobs with less deadline. All right, so these are my observations. Now how can I what do I say, how can I approach this problem? So we have observed, so I want maximum profit and I want to delay jobs. So for maximum profit, should I sort here according to the maximum profit? So what I can do, I can sort this array in terms of gaining maximum profit. So if I sort them, so this side I am writing profit and this side I am writing deadline. All right, so maximum profit is, I'm getting here, is 40, and 40, and deadline of 40 was 1. All right, and next I am getting is 30 profit, and then the next is coming 20, and then it is 10, and 30 was of 1 deadline, 20 was 4, and again here 1. So I have sorted the array according to profit. So I have arranged this in descending order, where maximum profit job is at the first, all right, and so on. So what I will do, I will try to perform job with maximum profit first. So now what I will do, I have arranged it. Now I will check. So now I will go on this job first. All right, I will go on this job first and ask if I can, if I have, let's say we have 4 days only because maximum deadline was 4. So day 1, day 2, day 3, day 4. So I will say I can uh, just say that check on day 1 if day 1 is empty, is day 1 is free. So here initially what I can do, I can create an array or maybe boolean array of size maximum deadline plus 1. So here what I can store, initially I can store them with false, and I can just ask on day 1 that is day 1 is empty, so it is telling false, then yes, I can perform a job 1. So now I will mark it as true. So now I'm going to mark this day 1 as true because it's now completed. Now it is true. All right. Now, and yes, I have to return the maximum number of jobs and maximum profit also. So maybe I can store a variable of maximum profit and let's say count of jobs. So if I can perform job 1, I would say that my profit is increased with this profit, that is now 40. I should write it below here. Now moving to this job, here my deadline is 1. I will ask on day 1, hey, are you empty? Are you can I perform this job on day 1? He says it is true. So it means that I have performed already one job with maximum profit here. So I cannot do a job now. So now if at any day I cannot do this job because its deadline is 1. So can I do, let's say I have to do a job before deadline X days, alright. So I can do this on day 1 also, day 2 also, up to X days if deadline is X. So I will go and check the day before the deadline. So I will check 0. So there is no need to check 0 because there is nothing like day 0. So I should stop on 1 only. Alright, so I will not move. But if let's say I was any other day and if it was filled, then I could keep going on the left to check that if on the last day I cannot do it, then maybe on the previous day or lesser days I can do it, because if deadline is X, I can do it on days less than equal to X. So I will keep checking. I can use a for loop starting from the deadline up to the 1. There I don't need to check 0. All right. So now moving ahead, I cannot perform this job. So moving ahead, now I will this job's deadline is 4. So I will check on day 4. Are you uh, are you available? So he says yes, it is false, it's available. Now I can do this job. Now I will increase it with profit 20. Now it will become 60. And count, yes, I was able to do one job, so count was previous 1, and now the second job has came, so count is increased to 2. Now this will be turned to true. Now again deadline is 1, it is already filled. I will go back. on the previous day, but day 0, there is nothing like day 0. I will stop. So now it will come out of bound, and I will return the maximum profit and count. So 2 will be the maximum number of jobs and 60 will be the maximum profit here. Now, so this was the whole logic, that I can sort the pair of vectors with respect to profit, because I have to gain maximum profit, and I will maintain a deadline hash array, we can say, so that we can check that whether the day is available or not, otherwise we will go back. So this way we can solve this problem. But what will be the time complexity here? So for checking each of the jobs, let's say n jobs are there, so we will go from from starting job to the n number of jobs. I will check every job, and inside I will use a for loop for this array. Let's say this is hash array, deadline array. All right, so I will move from the deadline to the one day to check if any day is available or not. So what will be the time complexity here? So time complexity, first of all we will solve. So this will be n log n for sure, and then here the time complexity will be n cross this for loop inside count complexity of deadline or the hash array. This will be n into max of d. So this n into max of d, this extra for loop inside can let us to TLE, but it is accepted in interviews, I think. But we can reduce this time complexity. How? We can use DSUs. So we all know about disjoint set union. So if you don't know, you can also solve this using the hash array also of true and false boolean array. But using DSUs, so what are DSUs? What we can do, instead of running a for loop, what we can do, we can directly find using the find function in the DSU that where I mean which day is available directly. We can directly check it. So how we can check? So let's say 4 days are there, 1 2 3 and 4 days are there. I can maintain a parent array. So this initially it is telling that 4 days are there, so initially size will be 0 1 2 3 4. All right, so initially I will say that parent of I is equals to I. So parent of 0 is 0, day 1 is day 1, day 2 is day 3, day 3 is day 4, because initially all days are available. So I will say if I have to check if this deadline is available or not, let's say I will check if I have to check is deadline 3, is day 3 available or not. So I will go and check the parent of 3. So if parent of 3 initially is 3, because day 3 is available initially, and as soon as my day will fill and I need to go on the previous days. So suppose if day 3, I said that day 3 is now occupied. All right, so whenever a new deadline will come with day 3, I would say that now you cannot perform a job on day 3. You need to go to perform that job on day 2. All right, so I will say that now parent of 3 will not be 3. Now parent of 3 will be 2. I will reduce this. Parent of 3 will be not 2. So this will be like, this will be marked to 3. Alright. So parent of 3 will be 2 now. Again, if any deadline will come, we don't have to just move from in the hash array from right to the first day. Directly we can use the parent array. And uh, how we can update this, we easily know that in DSUs we use a find function. So find function tell us that if I send here any day, let's say x, and the parent vector, so it can easily tell who is the parent of x. All right. So I will write here just the find function of DSU, and it will help me telling that directly that which day is available. All right. So if I tell you from this example, so I have sorted this, I will do the same thing. But instead of making this hash array, I can just use DSU. So in the DSU, first of all, I will having this parent array. Initially they will be uh, all days will are available, so parent of any day will be its own day. Now I will be on the first, I should delete this. So when I will be on the first index, so profit is 40 and deadline is 1. So I will check that who is the parent of, is day 1 available or not. So yes, it's available. What is the parent of, this is parent array. What is the parent of 1? So it is saying that 1 is only the parent. Now my answer will include 40. So my answer will include 40. All right. Now I will go to day 2, and now before moving I would say that I have to, now my day 1 is occupied. Now any deadline comes on day 1, I should say I'm not occupied. Now parent is changed to the previous one. So I would say that I should reduce the parent of 1 with, let's say, -1. All right. So I would reduce this by -1. So now this will be 0. Now this will come, deadline is 1. So deadline, it will check what is the parent of 1. So it is saying 0. So if it is 0, so there is nothing like day 0. So I would say that return nothing. Again, it will check the, it will come and check the deadline is 4. Deadline of parent of 4 is 4. So now I can say that it is available. So now profit will become, maximum profit will become 60. And before moving, the parent of 4 will be changed to 3, because now day 4 will not be available, day 3 will be available. So this way I can go. And again, now this will come, it will check, deadline is 1, it is 0, it will not add. So now this way maximum profit is coming 60. And this parent vector we can just create on our own, and using find function, using who is the parent of any day, we can just use find function in the DSU. So if I implement this, so what I said, first of all I will declare the size of the deadline array. Now what I said, I will have to sort them. So first of all I should create a new vector of pairs. All right. So this will be, let's say, VP, and now I will store all the deadline and profit in the pair. So let me store now VP dot push back. First of all, I have to sort them with respect to profit. So deadline of I. Now I will sort this in descending order. So vp dot r begin comma vp dot r end. Now what I have to do after sorting, I will go one by one. So I have to, let's say maximum profit now 0, and number of count of jobs, let's say 0. Now I have to iterate, and what will be the maximum deadline? So let's say the maximum deadline will be what? Max D will be what? The maximum deadline, the maximum element in the deadline array. So the maximum, so this is STL function, we all know. Deadline dot begin comma deadline dot end. Now what I have to do, I have to create a parent vector which will store which day is available on the deadline for the deadline. So let's say this is parent vector, and the size of this vector will be max d plus 1, and initially let's say they are 0, and I have to just go and mark the parent of all days equals to I. Alright, now I will iterate in the VP vector of pair of vectors, and what will be my deadline here? What will be my deadline here? This will be VP of I of, what is the deadline? Of 1. Now I will just check, I will check if it is available or not. So available, so let's say AVAL. Alright, so available or not. So I will ask find function to check if this deadline is available or not in the parent vector. Which deadline is available? If it is not available, you just go and check which day is available. Now if this available is greater than 0, I would say that maximum profit will be increased with pair of vectors of I and 0, and count will also increase. And now yes, and we have to just say that the day is occupied. Now parent of this available day will be available minus 1. Alright, now at last I have to just simply return the maximum number of jobs and total maximum profit. So this will be count comma max p. Alright, and now I just have to write the DSU find function. So it will be returning an integer, and it is find function, and it will be taking, let's say, an integer and parent vector and returning. I'm just passing parent vector with reference. Now if x will be equal to parent of x, then I will say that just return this day because it is available else I will say just go and find the day available next. And if I want to optimize this, I would store this also, because this is DSU optimization also. So I would say that is store also. So parent of x is equals to find of parent of x now, and here parent vector is also sent. So if I now just submit this and check if we haven't done any mistakes, then we are ready to go. So if we haven't done any mistake here, vp dot push the profit of I, deadline d line, in this line 25. So d line is what? vp of I of 1. Yes, because this deadline I am storing as the second index, so this will be okay. This is a pair, so this should be written vp of I dot second, and max p will be dp of I dot first. Now if I submit this, so if we haven't done any mistakes, so there is a mistake I think. vp dot push the profit of I, deadline of I. All right, I've sorted them. Max profit, max d. Okay, this array is max d plus 1. So I should say here parent dot size. All right, and parent of I is equals to I, vp of I dot second. And if I submit this now and check, yes, we have now solved this problem successfully. And if I tell you the time and space complexity, so we can see that we are sorting here. So this will take big O of n log n, and all right, this is taking big O of n log n, this is big O of n, this is big O of n log n, and finding maximum element will take big O of n, and then this for loop is taking big O of max d plus 1, and this for loop is taking big O of n, and inside I'm using this find function. So we all know that DSU find function is big O of alpha, where alpha is something constant value. So if I directly write here the time and space complexity, so time complexity is big O, if I write it overall, so big O of n log n plus big O of n times the alpha, where alpha is the time complexity of find function, and which is almost constant. All right, so if I write here big O of n also, then it will be okay, but uh, we should write here alpha also. This is some, but this is constant. And space complexity, we can say that we first of all are sorting it, and we are creating new uh, pair of vectors. So this will take big O of n time complexity. This parent vector will take big O of max d time complexity. So the overall time space complexity will also be big O of n, and time complexity will be big O of n log n plus big O of n into alpha of max d. All right, so this was all about this problem. I hope you understood. Thanks for watching. Till then, keep learning and keep upgrading yourself. See you in the next video.